Okay, hello everyone, and welcome to OAuth and Beyond, Modern Auth not only for the web. Since it's already far too late for such a presentation, we will be really quick. I am Filip, he is Dušan, and we are both principal software engineers from Vysoft. But let's face it, you didn't come here to hear about us or about our company, so just really quickly, Vysoft deals with print management solutions, meaning we have printers, we have distributed systems, we have microservices, we have monoliths, PC clients, Kubernetes, you name it, we have it, and we suffer on it. And with that being said, I have just two housekeeping items before we get to the actual nitty-gritty. First, Slido. Use code GeeCON room 4. You can also use the QR code. And secondly, we believe that practice is the best teacher. So to that end, we have prepared an interactive playground. You can either visit it via the URL auth-playground.online, or you can use the handy QR code. And all the live demonstrations will be actually shown on this playground. So you can follow along. You can check them after the demonstration. And also, the source codes are included. There is a client portion, just pure HTML, JavaScript, nothing fancy. And the backend authorization server is written in Quarkus, so might be interesting to see. It's open source. Feel free to do with it whatever you want. Just don't use it in production, please.
For various reasons.
For various reasons, yeah. So what's this lecture about? First, we start with what is wrong with passwords. Dušan over here is a notorious password hater, so he will tell you all about his passion. We will dive deeper into what's the difference between authorization and authentication, and where the line between OAuth and OIDC actually comes in. We will follow with two, let's say, core flows or grant types of the OAuth framework, which is authorization code flow, both the regular one and the PXE one, which we will follow with device authorization grant, which we also accompany with a case study, because this is something that we've been, let's say, working for a couple of years on with different types of devices and so on. So pretty much how you want to authorize devices that do not have a keyboard, do not have a screen, and so on. And since there is the Beyond word in the name of the lecture, we will also look into the future. And the future is passwordless, so Dušan is happy with that. And we will explicitly look into Webauthn protocol. If any of you are using your smartphones, you are used to it in, for example,
Don't spoil it.
Okay, don't spoil it. And with that, I give word over to Dušan, and he can guide you through the initial.
Hello. So before we get to what is modern on modern auth, let's review. Let's really recap what's not so modern. So in the traditional world, we can already identify the four systems that need to work in like a dance in order to do things on the internet. So at the beginning, there's us, there's users, also called resource owners, who are trying to use some application. It can be a front-end application written in JavaScript, or it can be a native one, or it can be, it doesn't really matter, it can be a server-side application as well. The important stuff is that the front-end application, the client, does not have the data necessary. It needs to ask for the data. So who it asks for the data? There has to be another server, like a resource server or backend server, which has the data. And in order, it doesn't just give the data to anyone. There needs to be some authentication or authorization. And that may happen also on another server, which is in charge of this stuff for the user base. This is called the authorization server. And now, in the olden days, people just used basic authorization header with name and password as a credential. And as you might guess, that is just very wrong. The password is shared with all the applications by design. It gives all the permissions that the user has. And so it's very bad. Bad things happen when this password leaks to some hackers in North Korea. Now, some people think that they resolve this problem by instead of using password, just use API keys. To me, this is completely the same. Like, it depends on the concrete implementations, but for what I've seen, API keys are just glorified passwords. They don't really solve the problem we have in hand. So what can you use instead? Since you all are here, you probably guessed it, we need a token. A token, or bearer token. A bearer token is just a long string. That's it. It needs to be long, random, and hard to guess for an attacker. Also, it needs to have short lifespan And usually it also has limited scope, so that when it leaks and the attacker has like 5 minutes to use it, they also have like limitations in what bad things they can do about it. And now I said that the bearer token doesn't have to have a specific format. That's still true. However, if we use a specific format, such as this one, JSON Web Token, abbreviated JWT and pronounced YOT, I guess you didn't know that, the pronunciation, YOT. If you use this, it is possible that your resource servers can actually avoid the round trip to the authorization with every token. How it works, the token itself actually contains the necessary data. You can see on the picture that it is actually containing 3 parts, last of which is the signature, and by the signature, the resource servers can actually verify the token is correct and can trust it. That's all to say about it. We're basically done, right? So we know how to authorize API. Now there's only one problem: how we can get those tokens. And for that, back in 2012, yeah, people got together and they invented the OAuth authorization framework. So it's 11 years old right now. Just a new version is coming. It's in draft this year, so there will be an updated version. It doesn't really contain that much new stuff. It's more like a reconciliation of the security practices over the years. And we were talking about this in the rest of the talk. Just a historic note, there was the version 1, obviously, before version 2 in 26, but that's really not what we are talking about today. It's more like a historic monument and nothing else. Nobody uses it. And the last note about this, the OAuth part in the OAuth, it means actually authorization, not authentication. So as I said, we get some tokens, and we can do stuff with those tokens, but none of these tokens tell us who we are, who our users are. If we want this information as well, chances are we actually came here to use OpenID Connect, which is like an extension, an identity layer built on top of the OAuth 2. And this OpenID Connect, or OIDC, gives us another token called ID token, which contains all the information about the logged in user. And this token actually has to be YOT. So enough for the theory. Let's see how the grants in OAuth work in practice. The very basic one, the very basic flow or grant in OAuth 2 is called authorization code flow or authorization code grant. And you may not recall the name, but you definitely know it. So let's just try it out. So if we have a client and we want to securely log in a user so that we can use their tokens for our reasons, the first thing we need to do, we need to build an authorization URL, and we redirect there. As I said, probably know it, so I will just go through very quick. We just need to apply a few parameters, some of which are hard-coded, like as the code, some of which needs to be pre-registered on the authorization server, such as the client ID and redirect URL. And some of others are completely on us, such as the scope. The scope is basically how the client can tell the server how powerful the tokens must be, what kind of resources they give access to. So now let's just click through that. Now you can see the domain changed. I can log in. I, as a user, can again review where I'm logging into. And boom, I'm back. I'm back at the URL that was specified beforehand with this parameter, a code. And now the client is supposed to make another request. This time it's a direct REST request with the code. So we'll do just that, again on the authorization server. Again with some parameters, some of them we've already covered, some of them are new, such as the client secret, and especially the code. And with that, we are supposed to get, this is called authorization code response, which contains various stuff, and among which is the token here, which expires in this many seconds. And we have another token here in case this is something like 2 hours, something more like 2 hours. And if we need a longer session, we may use a refresh token to get a new access token. And that's basically it, and I think you all knew it. Am I right? Who knew it beforehand? Yeah, great. Yeah, super. So you probably noticed that this, what I presented, was insecure, right? Right? Yeah. So how we can make it secure and how it was insecure in the first place. So there are basically two redirects there, and the attacker could misuse either of them to do bad stuff. So the first one is they craft another authorization URL, and the obvious thing that they do, they will just put their domain here. Well, it's easy. We just need to whitelist the redirect URLs, and that's it. How to prevent that. The other attack is more subtle. The attacker could also start the authorization flow with their own user, and then distribute via email or I don't know how this URL. And so the unsuspecting victim could instead end up logged in as the attacker. And you may be asking how dangerous that is. Well, for example, if they don't realize it, they can, for example, input their credit card info or something like that to the attacker's account. So all in all, there are various ways how to protect against both of these attacks and many more. But, and he already spoiled that, there is an extension of this authorization code flow, which is called this and pronounced PXE. In this talk, it means proof key for code exchange. We just call it PXE because it's shorter. So this extension basically starts with the client first generating some long and random string and then hash it. And if they do this, they will append the hash into the initial URL. We'll click through the thing again. And now at the end, when we actually ask for the token, we exchange the code with the token, the client appends the original string. And how, because how hashes work, it is very unlikely that any attacker would be able to compute the original string for a hash in that short time span that it took the user to click through all of this. Of course, this implies that the client has some way how to remember stuff across the redirects, for example, a cookie. And that's basically it. So yeah, you probably knew it. So let's get to the more interesting stuff. Back to Filip.
Okay. So I will switch to the presentation. Okay, and finally I'm on. So we have talked about the authorization code grant, how it's useful, what are the dangers, and all that stuff. But right now it's pretty much industry standard, right? Most of you have seen it. Probably everyone has used it in some capacity. But what do you do when you have a device that does not have reasonable input options? Well, you can use a device authorization grant, or as many of you may know it, actually a device code flow. So let's get into what it actually is. I've mentioned that there are devices with limited input options. What does it mean? I have, for example, smartwatches. Yes, I have some screen. I can emulate some keyboard, but it's not ideal. Or I have some simplistic hardware screen, for example. Or I don't have screen at all, and I just communicate with the device via OpenSSH. Or I have a screen, such as, for example, smart TV, but forcing someone to type all their credentials over and over again on the TV via the TV remote, well, not such a great idea. So how do we solve that? We introduce a secondary device. Usually would be your mobile phone, would be a PC, could be pretty much anything that has the capabilities that you actually need. And with that, let's take a look how it actually works. Hopefully. Okay, I cannot exit. Because I am dumb, that's because, okay. And we go back to the playground. And this time we choose the device authorization grant. You will see that it's really similar, but different in some meaningful matters. First, to initiate the actual flow, we need to call, in our case, the device endpoint and provide it with some basic data. In our case, it's just client ID because we have a public client. Usually, you would use also some client secret so that not just anyone can initiate this flow. And when we call this endpoint, we receive a bunch of information. First is a device code, which is a code generated uniquely for that device, and it serves for the device to periodically check with the server what's the status of the actual request. So in a sense, it's pretty much a token. Then we have a user code and we have a verification URI, which are crucial to finalize the flow on a secondary device, and we will get to those in a moment. Then we have interval, and interval dictates what's the recommended time between the polling tries to the server. Of course, we can disregard it, but then we would be risking rate limiting and being blocked out. And finally, we have expires in, which dictates for how long those codes are valid for. So if the user does not finish the authorization in those 180 seconds, we need to start over because those codes are no longer valid. And when we have all the info, we can actually begin. And as I mentioned, the first step is actually periodically polling the server to check what's the status. How do we do that? We call actually the exact same token endpoint that you saw in Dušan's demos. It's exactly the same one. We just modify the body data. We change the grant type. In the previous one, it was an authorization code. In this one, it's actually a device code because we are using, as I've said, device code flow. We have the client ID. If we would also have a client secret. And we are also attaching the device code. So let's begin the polling. And right now, we can see that when we call the server, we are getting authorization is pending because no one has finalized the actual flow. And at this state, we are pretty much waiting for it to end or until we get an error that the code is expired and we need to start over. What the device now would need to do is inform the user to actually perform the action. And that will largely depend on the actual device. On a smart TV screen, you would see a QR code that you scan, you log in, you are good to go. On some only OpenSSH, you would see in a terminal code and a URI, or maybe just some code on a hardware screen and a URI would be in the documentation. In our case, let's copy the code, open a new browser window, we input the code, then we log in as usual. This time, we did not ask for any scopes, so we just need to grant a general consent that we agree for this particular application to use our data. We confirm. And we see that the background thread that was running actually received a response and is exactly the same response as the token endpoint. So we used a secondary device to perform the actual authorization while the original device waited for us to finish and then obtain exactly the same stuff as it would get if it performed the regular authorization code flow. So we have the token, a refresh token, expiration, everything pretty much the same. And now the application or the device could easily access our authorized resources. So what are the dangers here? It's all about the fisherman once again, and it boils down to the fact that there is no authenticated channel between those two devices. So yes, you see some code on the screen or you see a QR code in your email or whatever, but you have no way to really verify that that code was really generated by the application that you think it is, and it was not generated by an attacker. So an attacker can initiate the protocol. Of course, if some client secret or some other measures are involved, it's harder, but it can still happen. And in order to force the user to actually perform the flow, they use social engineering. So typically what you would get is you get an email, you've been selected to our special program, you are eligible for some discounts. All you need to do is scan this bonus code, log in, and you are good to go. At that point, attacker's device gets the token and can access the resources as you pretty much and get the access all that it needs. So how do we prevent that? We basically have 3 lines of defense. First one is a prevention. If the attack cannot happen, well, we are safe. But as with any line of defense, everything can be overcome if the attacker is determined enough. And one for all would be trusted devices. So we pretty much allow only the trusted devices to initiate this flow. The trust can be on several levels. Could be just only devices that have client secret, but that's, as Dušan mentioned, it's just another password, just a fancier password. But could be, for example, hardware trust, meaning that we only allow devices that have a certificate, for example, baked into the hardware that we actually trust, and only those devices can initiate the flow. That builds really strong foundation. But let's say that we did not prevent the attack and the attack really happened. Then we can modify, for example, for how long those user codes are valid for. Of course, there is some reasonable limit. We can't make them just 5 seconds because the user will not have enough time to log in, authorize, and so on. But if we make it, for example, 30 seconds, it gives the attacker less time to actually carry out the attack, because who notices in 30 seconds that an email came, scans the QR code, logs in, consents, and everything, so it limits the capability of performing those attacks. Of course, we could have something like content filtering on the level of network, for example, in some corporations, so that QR codes are not allowed. If there is some detection that many of these types of emails are coming in, they are blocked and so on. But let's say the attack succeeded and the attacker got the token. As Dušan already mentioned, one of the protections is always to limit the scope. So if I have, for example, some streaming application and all I need to do is fetch the library of the user and start streaming the actual content, I don't need that particular token to grant me access to user payment details, to his home address, and so on. That's just, there is no benefit to it, and when the attacker gets the whole of that particular token, all the more damage. Or we could, for example, have sender constraint tokens. This pretty much means that the token, either via some software keys or hardware keys, can be used only on the device that communicated the token. So the extraction of those tokens, because attacker will usually carry out an attack on a large amount of users, and then he will try to offload those tokens and send them on a secondary market, when they are tied to that particular device, makes their lives much more harder. And this brings me to a trusted device enrollment, which is kind of a short case study of what we've been doing over the past few years, and it all boils down to establishing trust with the device. When you are in a zero-trust environment, you need to communicate with such devices where you are, for example, performing the device code flow and so on. You want to have some measure of trust, that the device that is really connecting, you can trust it. The first line of defense, as I've already mentioned, is a hardware-based trust. Typically, you would have a TPM, you would have some baked-in certificate, or anything along those lines. Really depends how far you are involved in the selection of the devices. If you have that fully in your control, or if you are manufacturing your devices, much easier. If you just outsource the program and it can run on anything, well, you cannot really do that. And also, when this is in place, it doesn't take long for someone to come and say, hey, we have those devices, and we know that each individual device is that particular device. It has the serial number. And by the shipping, by the ordering, and so on, we know that this particular device with this serial number was sold to John. So why can't we just make it the way that John connects the device to the network, automatically connects it to his cloud tenant, starts downloading data, starts functioning? Well, many reasons not to do that, but in the end, it boils down to the fact that there is no guarantee that John ever got that device. Could have been suddenly misplaced in the shipping, and we would know that. And when we know it, maybe too late. But as I've mentioned, the hardware-based trust is not that easy to achieve, especially if you don't know on what devices will your application run. And then you have the second line of defense. Of course, you can combine them, and we will talk about that in a minute. But you have a software-based trust. And for example, in printer industry, usually in the past, certificates were issued for all the devices. Each would have their own certificate that would be verified, would have to be renewed, and so on. But there are not good APIs, automation. It was a pain. And as Dušan mentioned, OAuth is a framework. And what you build upon it is pretty much up to you. So if you want to build something crazy, it's also up to you. But for example, you can issue tokens not only for a user, but you can actually issue tokens for a device. Nothing is stopping you. And then you can verify these tokens as an authorization tokens to even allow something to connect to your API. What's the benefit? There is shorter life cycle of the tokens. They are easier to manage. They are easier to issue. And pretty much fun all around. But in the end, it's always about the balance of security and convenience. I can have the most secure solution on the planet, won't be convenient. I can have the most convenient solution on the planet, won't be really that usable. And it's about finding that balance. And really depends on the individual industry. If I am manufacturing Chromecasts and I assume that a regular user will set up, I don't know, 4 Chromecasts throughout his lifetime, well, a few manual steps are fine. But if I know that my end customer is a partner's technician that sits in a warehouse and has to set up 300 devices during his shift, and I force him to go to each individual device, establish a hardware trust, establish a software trust, issue a certificate, do some mumbo jumbo, 3 times restart the device, there is a high likelihood that someone will find me and damage me with blunt object. So it's kind of about walking the line, and that's where, for example, the device tokens can come in. Basically, device initiates the code flow, as we've seen, requests the device token, starts polling the server. Pretty easy. Of course, we would use some form of secret to up the challenge for a potential attacker. And instead of going to each individual device, scanning a QR code, logging somewhere, administrator can just log in to cloud services. He can see all the devices that initiated this flow with some identification, some serial number, and so on. And based on that, he can confirm the registration of the device. And based on that, the device code flow is performed, device gets the token, and it can connect in a secure way to our API. So that's kind of the story that we took. We have many different approaches because we've been working with IoT, with printers, and so on. But still, we are all kind of dancing around the passwords. Still, the passwords are needed. And the talk begins with beyond. So what's the actual beyond, how it looks? And with that, I give over the word back to the notorious password hater, Dušan.
Yes, it's true. What can I say? Can we do without passwords? So, yeah, we've introduced together with Filip a few flows, how we can avoid people entering passwords to random forms over the internet or the internal network. We have limited to only one domain of the identity provider or the authorization server. But, you know, and come on. Let's try again. You know our users. When they get a reasonably phrased email from PayPal, they will just enter their password to any site it points to. How we can make them a little harder to make this mistake? Well, we can use multi-factor. So on every authentication after they enter the password, we can send them a code via email or text. Or on the other hand, we could require them to retype some time-generated code from whatever device, or we can send them a notification on their phone. But here's the problem. The attacker just picks a phone and they will call them, claiming they are their deceased father calling from hell. And that the only thing that will save him from the eternal fire is that they send them the code and people will just do it. So some smart companies and like big names, I don't know if it's really visible, they formed an alliance. They call it Fido Alliance. And this is, by the way, just the first page, like the core members of the alliance. The list goes on and on. If you can see it on the website. And they invented passkeys. And so passkeys, this is a quotation from the website. And they say these are replacement for passwords that provide faster, easier, and more secure sign-ins to websites and other. And unlike passwords, they are strong and phishing resistant. So do you wonder how can this work? And how can this work that, that kind of user I discussed before can use it without shooting themselves in the foot? Well, before we explain how it works, we need to say a word about digital signatures. I'm sure this is not the first time you heard the term. Shows that very quickly. Given that Alice wants to prove to the world that she attests, she signs a message, she will beforehand generate a pair of keys, a private key she will never share, and the public key she will share with the world. And she will do then some hardcore mathematics around the message and the private key to compute a signature with which anyone, especially Bob here, can verify that it was really Alice who authorized to sign this message. And of course, in our case, it works a little backwards, so that Bob can actually ask Alice, that you can generate a message for Alice, and Alice would sign the message, and this way prove that she really is Alice, or meaning she has the private key belonging to the public key, who we know is Alice's. Easy, right? Who can do it? So if, again, our average user is to use this stuff, we as developers need to solve basically 4 problems. We need to have a way where our user can store their keys without them knowing there are some keys involved. It can be a hardware device, or I will talk about it later. They need to somehow connect this device to a PC or a laptop or wherever they are performing the login. And we as developers need to have a way how to talk to this device from a browser, from a web page. And finally, we need to have some backend support so that we can store these new credentials. So let's go from the top, the device. Well, this is on the picture. You can see one of these devices. This is YubiKey. There are many other vendors. If you want to purchase, you are looking for something that says it's Fido2 compatible. But the great thing, your grandmother, who has no money, she doesn't have to do it, because chances are she already has an iPhone or an Android, or at least a Windows Hello compatible laptop, because all these three systems, they already include these authenticators, or the Fido itself. So for example, I can use my Android right here to connect, to log in on this laptop. So how do we connect these two devices when they are not the same? So that's for the CTAP protocol. Unfortunately, I'm not aware of any PAN name on this, so sorry. But this protocol is basically just a protocol that connects the authenticator device and what they call a client device where it's happening, the login is happening. And you can see they support four transport protocols, and you can notice all of them are short range. The Bluetooth, at least, is a few feet, few meters. The others, they need to be really close to the device. So that's it. We have the first 2 points covered, and we didn't have to write anything. This is all between the hardware and the operating system and the browser. So the other half of the problem, the browser API and the backend support, is on us as web developers. And this other half is called, or is covered in a specification called Webauthn. And about this, I won't speak anymore, because I will show instead. So let's get back to our playground. By the way, this is a playground. This is not for production use. It is a toy. You can show it to your kids. I tried. He wasn't impressed. But anyway, so the Webauthn, it's not connected to OAuth in terms of it isn't a different flow. It's really just a replacement of part of the flow, namely the password. So in here, I will be just using, again, the authorization code flow from before. But you can see the difference. No password here. Yay. So instead of password, I just need to enter my username. So my name is Dušan. So let's see. Yeah. And there it goes. So this is the first time my user is visiting this page. So we request something what is called a challenge from the server. So let's just do that. And did I mention this is easy? Yeah, so this. So the server now provides us with a couple of data. I will just pick the most important ones. There is an ID, which is basically a domain. Then we have some information about the user. Here is the challenge itself. It's just a random long string, hard to guess. Then the server can somehow decide what kinds of public keys, what kinds of algorithms it supports. Let's leave it for later. It can also specify how strong authentication requires. For example, this user verification means that I, as a user, will have to somehow prove that it's me. So instead of just clicking a button, I need to enter some PIN code, or better, provide some biometrics such as fingerprint or a face. This whole thing is timeouted, and that's about it. So what we now do, this is a JSON. My script will convert it in more native JavaScript types, all those byte arrays and stuff. And it will prompt it or pass it to this new API, Navigator credentials create. And when that happens, this is Windows Hello kicking in. Because this is not the first time obviously I use this page. It already knows what I'm going to do, but I just want to show you this. This is Chrome, by the way. So in a different operating system or different browser, it may look different. But in this case, it already provides me my phone, which I've paired before, or I can pair a new phone or new device. I could also use the hardware security key if I had one. And basically, the last option is what I will use directly, because this device, it's easier. So now I need to smile into my camera. If you don't see, but it's blinking at me. So yes, smile. And there we go. And I am registered. And the API, which basically returns a promise, now gives me this. Yeah, again, easy, right? So some ID. and now some encoded things here. The attestation object comes from the authenticator. So if it was a different device, it would be over USB or something transferred to the laptop. This one comes from the browser itself. So let's decipher it. The attestation object basically, again, it contains some data which is encoded, but if we decode it, here we see a couple of flags. Basically, it says that I indeed was verified by my face. I was also present. And here we have my public key, which was at this instant generated. And it shouldn't leave some trusted platform chips on my laptop. And we also have the other field I discussed. This is generated by the browser. And this contains basically, namely, the original challenge, some tasks for the server, and the origin. Again, a domain. This is not the first time I mentioned the domain. I forgot this is also encoded domain. It is the hash of the domain. So the domain is really omnipresent here. And finally, if I feed it up to my server, it will check everything, that everything is in the right format, and if I was really present as it required, I would, etc., etc. And basically, we are back to the original flow, which will just give me my tokens. But from this time on, I am registered. So what happens if I come back? So let's see. I again need to enter my username, preferably the one from before. But this time I click login. Again, some necessary dances with the server, and we get something which is pretty similar for what we've seen before with some changes. So again, we get a random challenge, again a random string, again a timeout, again a domain. And then we have a list of credential IDs that I registered. In my case, it's just the one from before. Again, the server can decide what kind of transports, etc., blah, 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 it can use. Not interesting. This, again, is fed to a similar API, just get, there was create. I need, again, smile into my camera. Smile, come on. Not enough smile. There we go. And my API responds with, did I already mention this is easy? So it is. So again, a client data JSON and an authenticated data, which will break up later. And then again, the signature. So this whole thing is signed by the private key that was generated from before, and the signature is here. And so this is all just basically metadata. Again, you know, not only metadata, the challenge is pretty important here for verifying the whole stuff. But yeah, the challenge, the original stuff that server generated, again, a domain. And this is maybe more interesting. Again, a hash of the domain. Again, the flags, like before, I was again verified. And then there's a sign code. This is just incremented every time it is used to prevent like replay attacks. And that's about it. Now the server, there is no key now, no public key. The server already has the public key, and for God's sakes, no private keys anytime. So there is the signature using the private key. So among other things, the server can now validate all the stuff if it all matches up. And if it does, and it does, I can continue and I can log in without any password. How cool is that? So yeah, so I will just continue with this is not really anything new. And I'm here. So now, who got that? Any questions? You can think it over. I have 2 more slides. So this is awesome. No more password. Weak or strong, just no more passwords. I mentioned like 100 times the presence of the domain name everywhere. So if, for example, our beloved attacker sent us to a Google.com instead of a Google, and we are blind, we don't really pay attention to those characters, we would be like tempted to enter our precious passwords there. Now we can't. It simply isn't possible because our browser does it. By the way, this only works over HTTPS, so that's another layer of protection. Again, I mentioned also that all the transports, they require physical proximity. Like in the case of Bluetooth, it can be 10 meters perhaps, but it's just really not possible for an attacker to send you identifications from Argentina, say, or some other country. So, I mean, basically all cool. But while the technology itself may be flawless, there are still the environments that need to also account for that. So, of course, now our users may have more than one credential. Maybe they change a phone, maybe they are logging from various types of laptops, or they have multiple security keys. So we need to provide a way how they can register multiple credentials. Also, we need to solve the problem. What if they lose them all? Then what do? Maybe we defer to passwords again. Yeah. Maybe we send an email to them, which is even worse, maybe. So, yeah, we don't have an answer for that. Maybe the answer may be just recently. This is really very modern, very new. Like last month, maybe modern. Big names like Google and Apple, they started synchronizing these passkeys with your Google and Apple and other accounts. So it's no longer true that the passkey, the private key, never leaves the authenticator device. It leaves. It is stored at Google servers. Whether it is a good or bad thing, it depends on your own considerations. Yeah, so that's about it. And by the way, yeah, did you spot it? There was a vulnerability in all of this. So maybe you can, yeah? Only one? No, many. But I know I'm talking about one. But if you have more than one, no. I just repeat. This was more like a education project. So don't ever try to use our code in production. And this is all I have. Thank you very much. And now there is time for your questions. Yeah, so how does one restore access if they lose the secondary device? I think I covered that. Yeah, basically the same thing. What device do you recommend to use for passkeys? So basically, I'm pretty happy with my Android device. Yeah, as I said, I'm using Chrome, so Chrome is able to pair these two pretty awesomely. So I'm just using that. Yeah, that's about it. Windows Hello, also pretty good. And he's using iPhone, and he doesn't complain either.
Yeah, works fine.
Yeah, the playground, that's our worth. Thank you very much.
Yeah, so we have a domain booked for a year, so if you like it, drop us a star on GitHub, and we know that we should continue with that.
Yeah. Can we shout it loud till it sticks? If your attendees work somewhere where many users log in and you don't support Fido, be the change. Please, yeah.
It is now a recorded fact at GeeCON, so.
Yeah, and just I think it was last week, Amazon joined the club and Google before them. So really, it is really something brand new and things are happening. And how are passkeys synchronized between devices? I think I covered that, right? So yeah, Google does it pretty recently. I am held as a hostage without more devices. You are bad luck for you. And I need my significant other to log into my passkeys protected bank account. Well, I guess you need to go to the bank and explain your situation to them. Too bad. Yeah, I think this one's already covered, right? And this one too. And what is new in the new OAuth? Why the new release? And so as I said, it is not really like anything groundbreaking. It's, for example, the Pixie stuff, if you still recall what I'm talking about, is now more or less mandatory for anything but those server clients which can really hold a secret. And even there, they are very strongly recommended. So that's for one thing. Maybe if you know what I'm talking about, there are two flows I didn't cover, and that was implicit flow. So it is now gone. It is not deprecated. It is just removed from the spec. But it was being frowned upon for a long time, so nothing really changes. And then there's another flow called resource owner flow, which is basically just send me your password via REST, and I will give you a token. This was also taken out. But that doesn't mean that if it's not in the spec, it doesn't mean that magically everybody stops supporting that. So it's just... Yeah.
Yeah, Twin Brother is out of luck.
Oh, I wouldn't be sure about that, yeah. You should probably use a fingerprint. I hear that fingerprints are different even between twins. So.
Okay, seems like all.
Yeah.
So thank you.
Thank you.